This video will cover question 71 from the 2018 ENSA paper. In this question we're told about Bt pesticide, which is used by farmers to kill insect pests. However, its widespread use can lead to resistance, which is caused by a recessive allele. So scientists have suggested that where Bt pesticide is used, some fields should be left untreated by the pesticide, and these are called refugia, and this method has been shown to slow down the evolution of resistance to the pesticide. So we're given some options here of why that could be. So ultimately we need to think about why it is that repeatedly using pesticide leads to the development of resistance in a population. Let's base this on our statements. Let's start with statement 1. When resistant insects breed with pesticide-sensitive insects without the allele, the offspring produced will be sensitive. Now you might be thinking, how can we say this with any guarantee? How could we be sure that this is correct? Well, we're told in the question that it's a recessive condition, or rather it's a recessive allele that resistance is caused by. So, in order to have the homozygous, in order to be resistant, you have to have the homozygous recessive form. Now, if a resistant insect with the homozygous recessive form breeds with an insect which doesn't have the allele, i.e. just has two copies of the dominant allele, all of the offspring will be heterozygotes. So therefore we can say with some confidence that the offspring produced will be sensitive, because heterozygotes only have one copy of the resistant allele and therefore will not show resistance if it's completely penetrant. Move on to statement 2. When fewer insects are exposed to the pesticide, fewer mutations occur that produce alleles for resistance. Now, although it may well be that it's mutations that originally caused the alleles for resistance, the mutations themselves are not caused by the pesticide. So there's no reason for us to believe that not exposing the insects to the pesticide will decrease the incidence of mutations. The rationale behind why is that pesticide application can increase the incidence of resistance in the population is as follows. If you have a population with some genetic diversity, carrying different alleles with varying extents, protecting them from pesticide use, if you apply a pesticide, then only those which are resistant to the pesticide will survive, and this population will come to predominate in the pest population. So there's no reason to believe that not applying the pesticide will stop the incidence of mutation, which is ultimately what causes genetic diversity in a population, which is in itself not a harmful thing. So the third statement says that the refugia help maintain genetic variation in the population of insect pests. Well, if we think about it, if we have a refugia, a nearby field producing pests, a pest population which is not resistant because it has not had this harmful effect of the pesticide on the native population, then it can crossbreed with the population that's been treated by the pesticide, and gradually, like through this crossbreed between homozygous dominant and homozygous recessive, help to outbreed the recessive allele from the population by giving them the dominant alleles that they carry. So, yes, the role of the refugia is to maintain genetic variation in the population. So our answer is that 1 and 3 are correct, and our answer is going to be option F.